This is the final lesson for Unit 1, Production Possibilities and Growth. Before we get started, I would like you and a neighbor to individually think of and then discuss the following question. How can an economy increase its productivity and grow beyond its current output? So how can we make more stuff? So now that you've talked about that productivity at the macro econ level, let's think about it at the micro level. Again, you're doing economics all the time and you don't even realize it. So consider this question, think about it, and then just briefly talk with a partner about this. How do you finish your chores more efficiently? And then what tools do you use to do that more efficiently? Turn and talk now. Alright, so when we're talking about production possibilities, generally we're talking about the possibilities that we can produce between two different things. And one of the biggest things that we'll talk about in our examples is the trade-off between guns or butter. And this example really sticks out in your mind from World War II, you learned about in U.S. history. So when the United States finally enters the war and we start shifting from producing cars and consumer goods to producing things like tanks and bullets and airplanes and bombs and all the things that we need for military spending. So when we say guns, we're talking about military production, and when we say butter, we're talking about consumer production. So things that you and I like nowadays, like cars and iPhone 5S's and whatever other technology we've wanted in the past, couches, home goods, things like that. So World War II is a really good example for you to consider. Are we going to make cars, or are we going to put Rosie the Riveter to work making bullets? So let's consider that. So you'll want to take notes on some of the things that we talked about just now over the next couple slides. So when we're talking about production possibilities, we're talking about all these people like economists, government officials, businesses, and individuals trying to strive to increase their productivity. So if you don't write anything else, I'd like you to make sure that you remember to increase productivity. That's really what we're trying to do. And we're trying to be more efficient, just like you cleaning your room. Because we have limited resources, which can be combined in various ways so we can produce a variety of goods and services. Now, when we decide what to produce, we have to make choices, and we all know the definition of economics is basically choices. And we have trade-offs and opportunity costs. And it happens at all three levels of economics: the national level, individual level, and business level. And one way that easily helps us do this is using a simple model so that we can describe the production possibilities. Our current production and then the potential production. So we have the production possibilities frontier or production possibilities curve. And we'll see this here in a second, but often you'll see the acronym PPF or PPC. And they generally mean the same thing. And it shows our combination of two types of goods that can be produced with the available resources that are employed fully and efficiently. So literally we have to limit it to two, because just like we've talked before in econ, we don't want our science experiment variables to be out of control. So we can handle two at a time and consider the trade-offs between those two. Alright, so we have to assume a few things before we get started. So really what we're going to be doing is drawing graphs and looking at tables. And one of the things that we have to do is not get too out of control and remember ceteris paribus. So everybody's operating efficiently, so that's important. We can't just make more trees or get more things. When we're talking about this frontier, this maximum amount we can produce, At least for right now, we're going to say that technology is constant, but later we'll talk about what happens when we do introduce these new things. And then additionally, like I said before, we're looking at two types of goods because our experiment will get too muddled if we look at more than that. So let's continue on. Alright, welcome to the office in Dunder Mifflin where we work with paper. So for this little scenario, you're going to have 6 sheets of paper for your table. You cannot tear the paper into smaller pieces, and you're going to produce one good with each sheet. So essentially you can't make more than 6 things. That's what we're limited to with resources. And then you do have a choice though. Here's your choice. You can make paper footballs or you can make paper airplanes. It's up to you. So what I want you to do now is in your group, and you can assign each other little jobs however you want. I'm going to give you 3 minutes to make paper footballs or paper airplanes. Your decision. Alright, so again, your resources available were those 6 pieces of paper. You chose what to produce. And here's a table that actually shows the different combinations of things you could have made. So you can see along the left-hand column that our resources were fixed. We always had 6 sheets of paper. Additionally, you could have made paper airplanes or footballs. So if you made all 6 paper airplanes, you could have made 0 footballs. If you made 0 airplanes, you would have made 6 footballs, and then any combination therein. Additionally, you could have been lazy and just made, for example, 3 airplanes and no footballs, and you had 6 total sheets of paper, so you left 3 hanging and wasted them. And we're going to talk about that here in the future, what that means. Alright, so additionally, besides just a table to tell the story of what's going on with our productivity between the two goods, we can also draw out a graph. So many of you are familiar with the X and Y axis and plotting points on a grid from your math courses. So here's the steps. It says 1, place each good on an axis. So we are going to plot what happened in the table. So we've labeled already our footballs and our airplanes on the axis. Here. Now it says 2, use a schedule to plot the points. So we had that chart from before. So really, we're just plotting the grids. So footballs was 6 and 0. So we made 6 footballs and 0 airplanes. The next one was 5 and 1. This of course is really simple. 4 and 2, 3 and 3, 2 and 4, 1 and 5, and then again 0 and 6. Alright, and then simply connect the dots. Alright, now that line is our production possibilities frontier or curve. So we can make anything within here. And we're going to talk about this more in just a second. Alright, so here again we have that same line that we just drew, but it's all filled in here. Of course. Now a couple things that I want you to write down to the side as you've kind of drawn along with me. So let's note efficiency. This means producing the maximum possible output from available resources. So remember when I told you could have made 3 and 0? If you made 3 and 0 here, you were being kind of lazy, alright? So we call that inefficient, so the opposite of efficient, alright? So as long as we're using all 6 sheets of paper here, we're along this line and we're being efficient, which is what we love in economics. We love efficiency. We don't want to waste anything. Again, your next bullet down here says the curve or the line represents what is attainable and efficient, right? So attainable means this is our maximum level here, right? This is our be all you can be line. Now it says the points along the line represent maximum possible combinations, right? So remember, we could have had the 5 and 1 combo, 4 and 2, right? Lines are literally just drawn in and filled in circles. We could have had the 3 and 3, 2 and 4, 1 and 5, and again 0 and 6. So as long as we don't have any introduction of a new technology or growth, or even a bad thing, and we'll talk about that in the future. It says, again, at the bottom, note your optimal or best product mix will be some point on the curve. Now, it says here that it depends on society, and this is a normative decision. So think about how the different combinations of your groups making airplanes and footballs. Some of you made more of one thing than the other, and that's your value. You liked planes better. Some of you would have rather played football. So that's a judgment call. Exactly why the United States spends more on military spending than any other country in the world, but maybe we judge them if they spend any more or less in a given year. Alright, so the next thing we talk about is whether we are being inefficient or we're looking at what's unattainable. So in this example, I here represents inefficient use of resources, but they are attainable, right? So we can produce 2 footballs and 1 airplane, and it's not an issue. We just are not meeting our full potential. We're not being all we can be. So any point that would be inside this curve is attainable, meaning we could do it, but it's not necessarily efficient unless we're right on the line. So anything up to the line. So I like to think of it almost as sometimes like a baseball field. Like our batter would be down here, and you can hit to the outfield. You can roll a grounder to second base and ground out. But in this example, you have not achieved the ability to hit a home run. You can only hit the wall. All right, and then additionally, U represents unattainable combinations. So this reminds me of like the space program. So again, we're production possibility frontiers. If you're a little nerd, and I'm not a nerd, but think about Star Trek and when that famous quote, "Space is the final frontier." So right now we've sent satellites to Mars, but we've never sent human beings there. So that's something that's unattainable, right? Like we know it exists, we know it's possible, or excuse me, not necessarily possible. We know that it's there, but we can't possibly reach it yet. So that's something that we're striving towards. So we'd love to invent something new, some type of new space shuttle technology that could get us there, but we haven't yet. So additionally, when we're doing our production possibilities frontiers, we can examine the opportunity cost or the cost of choosing one alternative to another in seeing the type of line that's formed on a graph. So that shape of it is going to show us the opportunity cost of producing more of one type of good over another. And we're going to show you that here in just a second. Alright, so now our production possibilities frontier can look 2 different ways. It can be straight or it can be bowed. In our paper football, paper airplane example, it was absolutely straight, just like it is on this top example, because we're using the same resources, and really it's not that hard for you to learn how to fold a football versus an airplane, and one's not necessarily easier than the other. So as you trade off from one to the other, you're not giving up more at certain end of the spectrum. But as we look at our boat out example here, this could be 2 products that aren't necessarily perfectly adaptable. So say we decided to make like a farm product, like maybe we grow watermelons in this example at the top. So I'll put a W for watermelons. And then the other example could be to, let's say, raise cows. So both are things that are grown on farms, but both take different types of skills. So as I spend a lot of time growing watermelons, maybe I spend all my time growing watermelons, I'm going to get really good at it, and I'm going to be an expert in that, and I'm not going to have to juggle my time. However, as we move slowly towards trying to make cows and farm cows, our skill set's going to have to change a little bit. So if we made all cows, again, we don't have to deal with the efforts of watermelon. But here, somewhere in the middle, is where we're going to be a good mix, right? It doesn't necessarily make sense for me to make like watermelons here where I make a lot of watermelons and only a few cows. It's still efficient, but there's a bow here because it's a learning curve, right? It's almost like you spending your time studying for history and then studying for math. They're very different subjects, and when you transition from one to the other, the skills aren't necessarily directly relatable. So history and English have a lot of writing and reading and synthesizing, where math is more problem solving and analytical thinking that don't adapt perfectly. And this is what causes our lines to bow, and we can actually graph that because we give up more here and here than we do here in the middle. All right, so I know we said that you can't move beyond the line, and that we're just thinking of a certain ceteris paribus scenario where we have two examples, but we can move towards considering outside factors changing our production levels. So think about this focus question and then turn and talk with a neighbor. What are some real world examples that you can think of that would allow us to produce beyond the frontier? So what could make us get to Mars? And then what about less than the frontier? But it can't be because of just being inefficient or lazy. Like what outside factors would prevent us from producing what we currently can produce? So think about those things, and then we're going to talk about it. All right, so you've brainstormed some of those ideas that's going to let us move beyond the frontier or would restrict us. So let's show what that would look like. So we've got our classic example up here again, guns and butter. I'm going to draw a little bit on here to kind of illustrate it, because you're going to do this here in just a little bit for your own practice. So some of the ideas you thought of that could bow the production possibilities frontier curve out are a number of things, but one of the biggest and best examples is always technology, right? We always think that technology makes us more productive. We can replace human beings, and then we can lower our operating costs, and that's a good thing, and we can make more stuff with the same amount of resources we had before, so it's hopefully going to increase our production. And so what we need to do to depict that, a shift of a change of a thing that can help us, would be drawing our line bowed out and to the right. So up and right is always our growth away from the axes. So growth and expansion of production would look like this. So this has made overall our economy increase. So we're making more guns and butter. And we could even draw little arrows to show it growing outward. So whoever would look at this wouldn't be confused about which line was first. So always using different colors helps show that movement, and then additionally arrows, because if I just saw this now, I could have thought that maybe this was your first line and then this one was the second, and that would be a decrease, and we're going to show that now as well. So let me erase these things, and we'll show that now. So let's look at a decrease. So maybe all of a sudden Hurricane Katrina happens again, and now our production is limited because we had just factories all over the southern part of the United States are wiped out. So we're obviously not going to be making as much stuff, even if we're working our butts off and trying to be as efficient as possible. So our graph would look like this, and we would draw our arrows down like so. Alright? Now let's look at another scenario. It's not always going to affect both equally, so we have to consider that. So, erase this. Let's say something happens with some kind of like metallurgy, sounds like some science talk, right? So all of a sudden we figure out a new way to make metal easier, and it's going to make it cheaper and easier to produce guns. But most likely it's not going to have any effect on butter, right? Butter, we eat cows, and we're using the dairy that the cows produce to make butter. So a new metal is not really going to help us except for maybe the input of the machine. So we draw it like this. We're going to have a new growth of guns, but our butter is going to stay the same. Like, we don't really get a bigger production shift or change in the amount of butter. So we would have an outward movement here. We have growth, but it's growth that's not perfectly adaptable to both items that we're producing. Now the next thing would be, maybe it just happens to butter and we'll use a decrease, for example. So maybe all of a sudden we have mad cow disease in America, cows get sick and we can't produce butter as easily, so maybe our production of butter drops, but it doesn't affect our guns at all, so it would look like this. And we'd have a contraction, a decrease in production. Alright, so those are some of the scenarios. So you're going to have some individual practice here now. So to round out this lesson, your individual practices, you're going to complete the production possibilities frontier problem sets that you've been given. And then once you've done that and we've discussed it, we'll move on, and you're responsible for completing the Lesson 7 Essential Economic Terms, remembering to define the term, give an example, and then also give a non-linguistic representation of that example. So some mnemonic device to help you remember, probably a picture, something about that term. So when you're asked questions on an exam about that, you can recall it.